Hello viewers, in today's class we are going to discuss yet another problem from definite integrals involving signum function and greatest integer function, right? So here we have to evaluate this integral from -1 to 0, and we have signum of x minus 2 divided by greatest integer of x minus 2, right? So let us start and let us first call this integral as I. Right now here we see that this integrand, it involves the signum function and the greatest integer function, right? And here in order to evaluate this definite integral, we have to make use of the definition of signum function and the greatest integer function. Now let us take this integral as -1 to 0 f of x dx, right, where f of x is given by signum of x minus 2 and greatest integer of x minus 2, right? So now let us first see the definition of signum function, right? Now we know that signum of y is equal to +1 whenever y is greater than 0, and signum of y is equal to 0 whenever y is equal to 0, and signum of y is equal to -1 whenever y is less than 0, right? So this definition, it implies that signum of y will take +1 value for all those values of y which are greater than 0, right? And signum of y is 0 whenever y is equal to 0, and signum of y will take a -1 value whenever y is less than 0, right? So now here we have signum of x minus 2, right? So here if we compare this expression with this one, we can take y is equal to x minus 2, right? So signum of x minus 2 is +1 whenever x minus 2 is greater than 0, or when x is greater than 2, right? And signum of x minus 2 is equal to 0 whenever x minus 2 is equal to 0. It implies that x is equal to 2, right? And signum of x minus 2 is equal to -1 whenever x minus 2 is less than 0. It implies that x is less than 2, right? So now if we take this number line, and here we have x is equal to 2, then we see from this definition that all the points which lies towards the right of x is equal to 2 are greater than 2, and to the left of x is equal to 2 we have x less than 2, right? So in this part, excluding x is equal to 2, the value of signum of x minus 2 has -1 value, right? And in this part where x is greater than 2, the signum of x minus 2 will take +1 value, right? And for x is equal to 2, signum of x minus 2 is equal to 0, right? So this function signum of x minus 2 will be 0 when x is equal to 2, right? Okay, so now let us take a look at the limits of integration. So here we see that -1 is the lower limit and the upper limit is 0, right? So our 0, it lies somewhere here, and -1, it lies somewhere here, right? So now we see that this function f of x is to be, we have to integrate it from -1 to 0, right? So the limits of integration are from -1 to 0, and when x, that is this variable x, it lies in the interval -1 to 0, all the values of x are less than 2, right? So signum of x minus 2 will take the value minus 1 when we integrate from minus 1 to 0, right? Because for x less than 2, signum of x minus 2 has the value minus 1, and when we integrate from minus 1 to 0, all the values of x which lies in this interval are obviously less than 2, so signum of x minus 2 will take the value minus 1, right? And now let us consider this greatest integer of x minus 2. So now again let us take a look at the limits of integration. So here the limits are from minus 1 to 0, right? From minus 1 to 0, and we have to decide the value of greatest integer of x minus 2, right? So what we will do, we'll subtract 2 throughout this inequality. So subtracting 2 throughout, we have minus 1 minus 2, here we have x minus 2, and here we have 0 minus 2, right? Because we need x minus 2. So now we have minus 3, here we have x minus 2, and here we have minus 2, right? So now we see that this x minus 2, it lies between minus 3 and minus 2, right? So the greatest integer of x minus 2, from the definition of greatest integer function, the value of greatest integer of x minus 2 is equal to minus 3, right? So now we see that signum of x minus 2 has the value minus 1 when x lies between minus 1 to 0, and similarly when the greatest integer x minus 2 will have the value minus 3 because x minus 2 lies between minus 3 and minus 2, right? So now this is 1 over 3, minus and minus get cancelled, so our function f of x is equal to 1 over 3. So now we can write our integral I as minus 1 to 0, and for f of x now we'll have 1 over 3, and this is dx, right? So this is 1 over 3, we can take it outside, so we have minus 1 to 0 dx, and this is 1 over 3, and the integral of dx is x, and this is x, limits are minus 1 to 0, and we have 1 over 3, this is 0 minus minus 1, and this is 1 over 3, 0 plus 1, and this is 1 over 3, right? So viewers, the value of this integral is 1 over 3, right? So this is how we solve this problem.